Hey there, Advanced Math. Oh, I forgot to change my title. Today we're going to continue talking about proportional relationships, but we're going to move on to situation and strategy number 2, which is coordinate plane. So, you can probably find yesterday's page and update it, but if you want to do a new page too, that's okay. So, strategy number 2. So let's talk about the coordinate plane real quick. When we did ratios in the 6th grade part of the year, we would look at a situation like this. Say a bag of fruit you can buy has 2 apples in it for every 3 oranges. And, we would kind of make our table of the ratios. If it has 2 apples, then it has 3 oranges. Or if it has 4 apples, then it has 6 oranges. And if it has 6 apples, then it has 9 oranges, and so on. And we would make our coordinate plane. I can only really have a positive number of apples and oranges, so I'm just going to really make my coordinate plane only have quadrant 1, because there's no sense, even though we later learned, we can have negative values here, and negative here, and negative here. It doesn't really make sense in this situation. So I really only need my apples and my oranges. And we could graph those as ordered pairs on the coordinate plane. So we could say like 2 apples, 1, 2. Then it would have 3, 2, 3 oranges. Remember, we count lines, not spaces. So this is 1, 2 on the lines, 3, 4, 5, and so on. 1 on the line, 2 on the line, 3 on the line, and so forth. 4 apples, 6 oranges, 1, 2, 3, 4, 5, 6. 6 apples, 9 oranges, 6 apples, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. And what was cool about this strategy is it showed us 2 sets of things we hadn't made. So one was that was weird. Went through my points. Remember, this was one of those you had to do it exactly right, which was not always easy. But if you did, now I have my line, because I can buy any combination I want, right? More this way or not really more this way. So I could also look and say, hey, there's another point, and that's probably where I buy 2 more apples and 3 more oranges, and so I could find other ones. Or I could even think about like what this would mean. If I bought 5 apples, that would mean in my ratio there were like 4, 5, 6, 7, 8, 9, 10, how many? 5 apples, there'd be like 7 and 2/3 oranges or something like that if I were to keep the same ratio, which obviously you can't do, but and so on. And so I could keep finding points all the way up there, stuff like that. So that's how that worked. So let's apply that to our proportional relationship problem. So here's one we did yesterday. Yesterday we found, yes, this is a proportional relationship of blue tiles and green tiles because every ratio I could make had the same ratio. They were all equivalent to 1/3 of a ratio. So we said they had a constant of proportionality, which made them, yes, a relationship. So let's talk about how that looks on a graph today.
You gotta see how hard.
All right, let's get this graph paper turned on, and we'll show you how this works with a graph. So I'm going to take this same situation with my green tiles, and I'm going to make a graph of the situation rather than a table, so you can see how it works. So I'm going to put my dependent variable on the y-axis, this is y, and my independent variable on the x. So remember we said yesterday the number of green depends on the number of blue. We would kind of say if there's 1 blue, then this depends. If there's 2, then this depends. So this is going to be my dependent. My y was my green, and my x was my blue. And let's see, when there were 0 blue, there was 0 green. 1 blue, 1, 2, 3 green. 2, 6, 3, 9, and 4, 12. So there are my, nope, I didn't do that right, I don't think. I can already tell there's something wrong. Go back here. 1, 3, 2, 1, 2, 3, 4, 5, 6, 3, 6, 7, 8, 9, 10, 11, 12. That's it. So double check my points, but I think I got them right that time. And so if I connect them all with a line, then I can see my situation well, and I can see future points on my graph and things like that. And so here's a graph of this table. Now you already know from yesterday that this is a proportional relationship, right? If you're using a table, this constant ratio, constant of proportionality is how you know. If you're using a graph to see if we have a proportional relationship, you're looking for 2 criteria. 1, the points, or ordered pairs, are in a line. So like when I connected this, all the points were lined up in a line. So that's the first thing I need. And 2, the line that you make passes through the origin point. And if you don't remember that word origin, that's the 0, 0 coordinate point. So this, you already knew this was a proportional relationship. If you're going to look at a graph, you can tell because it's a line, all the points are in line, and it does go through that 0, 0 origin point. And if those 2 things are met, then yes, it is a proportional relationship. Let me do one that's not, so you can see why. So if I go to my next one that we did yesterday, this was Ryan swimming laps. And you'll remember yesterday we did not have a constant of proportionality. Each ratio had a different outcome, and they didn't match, so this was a no. So what I'm going to do, I'm going to pause so you don't have to watch me make the graph, because that takes a long time. I'm going to make a graph of all these points, 2, 2, 4, 5, and so on. And then when I unpause, it'll just be there, so you don't have to watch me do it. So I'm going to pause now. All right, and there it is. So I've got my minutes on my x-axis and my laps on the y. And so remember I said to see if this is a proportional relationship, we're looking for 2 things. The points need to be in a straight line, if this is your strategy. And it needs to go through the origin point. Now, if you just glance at this, you might say, oh yeah, that definitely is in a straight line. And it is awfully close. But if you look somewhat carefully, they're actually not quite in line. You can't be too rash here. If I try to draw a point through all of the points, like I can get some of them, but I can't get all of them. You know, if you really looked at it carefully, it kind of zigzags a little bit. I would have like this, then this, then this. And, you know, looking at this, I don't really know what the next thing would be, because it's like +3, then it's +2, then it's +3. Like it's not a steady increase. As this goes up by 2, this doesn't go up by the same amount. So this does not meet the criteria because it doesn't even make a straight line. And I can't even check number 2 unless it does. So since these points don't line up when I make a graph out of it, it's not a proportional relationship between those. So he's not doing these things in an equal ratio. Like at first 2 minutes he does 2 laps, the next 2 minutes he does 3 laps, the next 2 minutes he does 2 laps, the next 2 minutes he does 3. There's no proportion, there's no ratio here that is equal. All right, find your examples from yesterday And let's do them together. So here was our first one. This one was a proportional relationship. If you remember, our constant of proportionality was 1.5 each time. So Wayne is swimming every 3 minutes. He's doing 2 laps. 3 minutes, 2 laps. 3 minutes, 2 laps. 3 minutes, 2 laps. So he does always have the same ratio. So we always had this proportional constant of proportionality, and it was. So what I'm going to do, I'm going to pause and I'm going to make a graph of Wayne's laps, and I want you to do the same. And then you pause, I'll pause, and then when we unpause, we should be back to normal. All right, there are my 3 points. Notice they're lined up. I could keep going, right? He could do another 3 and another 2. You know, I can keep doing this as long as I need to see if they're lined up. They look to me like they are. And if I use my straight line tool, and I can probably get these all on the same line, yeah. So if I make a line that shows how many he would do if he kept going, I'm looking for 2 criteria. 1, do I have a straight line? And I do. And 2, does the line pass through the origin point, which is the 0, 0 point. So in a proportional relationship, you've got to have 0 minutes be 0 laps, or 0 things be $0. And you'll notice it does. I could put that point on there, and it makes perfect sense in the situation, right? If you did know, 3 less minutes, 2 less laps, 0, 0 is a point that makes sense in that relationship. So it has that too. And if it meets those 2 criteria, it is a proportional relationship. So if you use the table, you're looking for constant of proportionality. If you're using the graph, you're looking for a straight line through the origin point. All right, let's turn to your non-example, and let's do that one as well. So this one was kind of random, right? This one was not related to anything. So we kind of said yesterday, well, I just have to pretend what X and Y are. Maybe it's dollars and apples. Maybe it's miles and hours. Maybe it's floors and workers. We do a lot with that one. But either way, this one we checked yesterday, we did not have a constant of proportionality. We had a different ratio every time. So this was a no, not a proportional relationship. So again, I'm going to pause. I'm going to make a graph of these ordered pairs. I want you to do the same. And then you unpause when you're ready. I'll unpause when I'm ready. And we should be able to see this pretty well. All right. There is my x-axis, whatever that means. My y-axis, whatever that means in this problem. I don't know. So here is my 4 ordered pairs, 3, 8, 4, 10, 5, 12, and 6, 14. Make sure yours is similar. And to decide if this is a proportional relationship, I'm looking for 2 things. Are these in a straight line? And does the line pass through the origin? So you don't have this handy straight line tool. I do. Kind of makes this easy for me. So I'm gonna connect these with a line. Would be about. I kind of missed my first one. Try again. It looks to me like they're in a line, but with the straight line tool, I gotta nail it. There we go. So made my line, and this, we presume this would keep going forever. And so are they in a straight line? They are. My straight line tool only lets me make straight lines, so those were definitely in a straight line. So yes. However, the line does not go through the origin point to 0, 0. 0, 0 is not part of this data set. And so that gets a no. So this is not proportional. And that is how you use a graph to find whether a relationship is proportional or not. Hopefully this made a lot of sense to you. Please go back and watch any of these 4 examples again. If you need some extra assistance, make sure you can use graphs and charts now to identify proportional relationships and justify why. See ya tomorrow.